Right, okay. Thanks all for coming. This is more of a sort of exploration, explanation of where we are and where we're thinking of going with the lab addressing, and with a particular emphasis towards the end on IPv6, which is going to become quite important. So what we're going to do is give a brief overview of the current IPv4, some thoughts of what we're doing within the lab on IPv4 structure. Then Ed's going to do an overview of IPv6. We'll look at some of the things that IPv6 potentially gives us as huge benefits, and also some of the potential gotchas. I was going to say downsides, but it's not a downside, the thing you've got to look out for. And then look at the possible IPv6 structure within the lab. And we'll also discuss some of the weird, wonderful problems you're going to get because IPv6 we have unusual device types in the lab, and how IPv6 will manage that, or how we'll manage it with IPv6. So at the moment, so when we first started this crazy thing called Linaro and the lab, we had we used a 192.168.1.x range because we had about 4 devices. The lab started to grow. I did something when we moved to the second office. I did something a bit naughty. I broke the rules. I went for a 192.168/16 address range because we'd run out of space. I know that's a very naughty thing, but so when we moved, then we sat down and thought, no, we're going to go for the full /8 address range, and put it on the 10.x.x.x, and we planned out various subdivisions. So 10.0.0.x. So 10.0 is infrastructure. 10.0.0.x is servers. .1 is PDUs, etc. Then .2.x.x is production dispatchers, 3 staging dispatchers. It goes on. It's all broken down. So the advantage of this from our perspective in the lab is that we can look at an address even if we don't know what the device is, and we've got a really good guess of what sort of device it is, even if we don't know specifically at that point which one it is, although we've tried to be careful so that PDU 10 is 10.0.1.10, so you can actually go, oh yes, I know that's PDU. And then there's the 254. There's the 254 range, which is DHCP served to the devices under test. There are some devices in the lab which are LAVA devices, which are given fixed addresses for various reasons, such as the Junos and the TC2s. We TFTP boot them, but that requires a Pixie boot type response. So we have to set up a config for a specific address saying, oh yes, and make sure I can't remember what the field is, but there's a field you have to have which has to be returned to the Juno, or it just, when you try and TFTP boot, it just goes, oh. So that's where we are at the moment. Now, there are potential downsides for that. The idea at the moment we've been discussing, and this may change actually on the basis of discussions we've had over the last few days, but we were going to keep the 10.x.x.x. We were going to subnet in groups, so 10.1, 10.2, 10.3 would then be dispatchers or devices, that sort of thing, but probably rack based, so anything connected to a particular switch would be in a particular group. The details of that haven't really been worked out, but Ed's been working on some potential diagrams that that we can actually bench test in this little application to see how well they work. But we're talking about introducing higher security with access control lists, and vary the DHCP lease times for certain device classes, because a server's a server, it's not going to renew its lease very often, but it becomes a problem with lots of test devices, because they quite often reboot and go and renew their DHCP lease, and if they're off for a long time and the lease time is 2 days, you can start using up. I mean, I know we've got a very wide range there. It's unlikely we'll use 65,000 in a few days, but you never know. So those are the things we're sort of thinking about. We can talk a little bit about that, but actually, what I'd like to do now is hand over to Ed, because up until I've read up on IPv6 and mostly gone, oh, I've got a friend who works in this industry who does network infrastructure stuff, and I asked him about IPv6 and he went, but he knew of it, he just didn't understand it. Anyway, turns out Ed does understand it, so in the last couple of weeks I've had a bit of a broadening of my knowledge. I wouldn't say I'm by any means an expert. So I'm going to hand over to Ed to give us an overview of the way IPv6 addressing works. If you all know this, then I apologise, but does anybody understand IPv6?
Oh, I don't know about understand it. I use it, so that's
right, yeah. Okay.
I use it.
Okay. Well, basically, we've got the example here. The green numbers are given to you by your ISP. They would be equivalent to your network address in an IPv4 world. The blue numbers are if we wanted a subnet. Basically, with the old IPv4, we would have had a 32-bit number or 32-bit address, and then we would slash annotate how much of it was going to be the network and how much of it was going to be the hosts. We can still do this with IPv6, but because the numbers of addresses are so great that they've just limited it effectively to 12 bits that we need to break down into networks. So the blue bit is still in the network element of the address space, and then the red one is the interface. It gives us, I think it's a Udecillion, a number of devices. It's stupid amount of devices. As you can see, we've got the slash annotation for where the network finishes. So a typical IPv6 address is a /64. Okay, and that's what we would be working on. You could see a /48 or a /51 if it was subnetted. Okay, and the subnetting rules of IPv4 are exactly the same here in IPv6. So basically, we're going to end up with loads and loads of interfaces addresses on either a network or subnetworks. And we can then obviously, it gives us up to 65,000 subnetworks that we could use, which is more than enough even for the lab. Any questions on the addressing? It's obviously a hexadecimal number, which we can even make it look as if it was an IPv4 number as well, which makes it
so you can use a dot notation after the first bit and still have make a 192.168.1. So you sort of go, oh yes, I understand that bit. The rest of it, not sure.
And the red bit is like the red part is a MAC address of the interface.
Right. There's two types of addresses. That is a global address. Starts with 2001. That's a global address, which means you would be able to access that from anywhere in the world for that one device. When you set this up on a network, you start IPv6, you'll see that it will give you an FF80 number, which is like your local network. So you have two IP addresses. You have your global address and then you have your local link. And your local link is only relevant for you on your own network. So when you're, which is built up on the MAC address of, your MAC address is changed somewhat. Basically what it does is it looks at your MAC address. Your MAC address is only 48 bits. They need to make it up to 64 bits. So what they do is on the 7th bit they flip it, and then in between your MAC address they'll put FFFE. So if you on routers you can set your MAC address so you can make it appear so that your local address is known to you and it's not just a random number of characters. What it looks like.
I was curious about how privacy addresses come into this, because I know when I run it, usually have 8 IPv6 addresses on my system all the time, and they're always changing and rotating. And to some extent, I'm not sure how. I get the sense that you have a global ID, but
Yes.
How does the MAC address and how do the privacy addresses kind of map in here?
You get, I think it's there's quite a few different addresses. You may or may not know, ARP is now, with IP version 6, we don't use ARP. What happens is it multicasts, which basically it looks at the address that you want and it sends it as a multicast group, which is almost identical. And if it gets any reply back, then it knows someone's on there. Basically, when you set up a group or set up a network, it automatically enrolls itself into an FF02 ::1 group, which is basically everyone on your local network. So if you wanted to broadcast, you would send out to that multicast group. It really is a broadcast, but it's sent out as a multicast. So when you look at your IP version 6 addresses, you'll end up with, like you say, about 6. But you'll always see an FF02 ::1. Your local loopback is ::1. And these are always sort of listed in, so it looks as though you've got a lot of addresses. But the main one, you'll only have a global address, and then you'll have your local link address, which is made up from your network and your MAC address.
So we have the rather unique situation in the lab of some devices which have exactly the same MAC address on 2 Ethernet interfaces, or 2 devices which have exactly the same MAC address. How does IPv6 handle something crazy like that?
Okay, if we have 2 devices that have the same MAC address, if they're on the same internal network, that's a problem.
Yeah.
But if they're on a different network, what it does is it takes the interface that it's working off, and what you'll notice, you'll get a percentage and a number, and this number is generated sort of as random, but this tells it which interface you're actually working from. So if you had someone with an identical MAC address, or therefore the local link address is identical, it would then detect that it isn't on, on your network, or that segment doesn't have it. So therefore, it would allow it.
So we still have the same problem as we do with V4, which is that in V4 we have to put the 2 on different networks.
Yes.
Yeah. So we still have to do that.
So we'd have to. That's what I was saying about subnetting.
Yeah. No, I understand.
I
mean, the way we do it at the moment is physically a disconnected switch, a switch on a different network. But the way we are going to do it in the future is on VLANs.
Yeah.
So that would all still apply. But it doesn't get us round this rather crazy problem. This is an issue for not devices that have the same interfaces, the same MAC address on 2 of its interfaces, but more for where we've got devices that have been delivered with duplicate MAC addresses, so we need to deploy 5 of them into production because they all have the same MAC address. So that's not something we can really get over at all, is it?
We cannot override the manufacturer MAC address with another one, because I think that in some cases we can pass
so that's
a different MAC address.
So that's what we can do. The thing is, we're going to have to start tracking MAC addresses.
We are doing it anyway.
Yeah, no, I
for
know.
other purposes
Yeah.
right now.
Yeah.
So maybe the immediate solution, not solution, or workaround to this problem would be just to generate a MAC address that we can pass to the kernel, or when it actually
Yeah.
to boot.
Well, if we're using the one we were talking about yesterday with the DHCP daemon, if you had it, so they started up on a network, and then they went into a different VLAN once they had started.
Oh, if they're on a different VLAN, it's not really an issue.
Yeah, no, but if they started on a network where we actually got them to boot up, so they then got their new address and then joined another VLAN,
Yeah.
and then sort of came into production.
Yeah, I mean, we have to look at the only option if we get, this is more of a message to send back to the members. Don't send us hardware that's got the same MAC addresses.
It is by definition broken.
Sorry?
It is by definition broken.
Yes.
Yes.
Yeah. I keep getting asked why a particular device we've only got 1 in production when we've actually got 10. Well, because
That's all we can use.
so in this particular case, I've been given the information on how we can reflash the MAC address, so we can do that. But the trouble is, MAC addresses are usually assigned. You're given that the top range is assigned to you, and then you just increment the counter and put them on the board, boards as you produce. And if you're not doing,
Often with the embedded stuff, there is no MAC address, and
No,
it's
no.
generated randomly at boot. Like it's one of those like.
Oh yeah, we've got.
like.
That's
have
easier to deal with.
Well, yeah, I mean, that's hopefully.
But we do have some boards which have booted up with a random MAC address. You go, thank you.
But if you know your MAC address, you can actually see where you can actually predetermine what your local link will be, which is quite handy. And on the Cisco routers, you can set the MAC address. Therefore, you're guaranteeing, because that's what you would actually enter in as your default gateway. You wouldn't enter in a global address. You would have your local link address as the default gateway.
So what I think this does, when we move to IPv6, one of the problems we've got is that for devices under test, they are in that 254.x.x range, and you don't know which one they're going to have. Each time you boot up, they could be completely different. And in fact, Bernie, who was going to come to the session but said he had a session clash, wanted to know about this because he'd like to be able to guarantee that every time a particular board comes up, that if it's a test device, that it has the same MAC address. We can do that, the same IP address. We can do that by populating the DHCP config. But what IPv6 does is it just says it's going to have the same address every time, which is great. So we've got the concern, you've got this global address, the 2001, which means that the outside world can see that device unless you do some firewalling, right?
Yeah, but you've got to allow it through. Yeah.
So you have to. Is it an explicitly allow or explicitly deny?
I think it'll be denied unless you allow it.
Right. Okay. So that's.
That
Which
probably depends on
people
the,
finally learn.
Yeah.
on the configuration. I mean, IP tables, for example, if there's no configuration allows everything, you have to explicitly tell it to deny everything and then to allow specific things.
It depends on how the
IP6 tables
files
might be the same. If you don't tell it explicitly first to deny, it just
well,
allows
I think that may be the case because I know that Matt at his previous company, when they implemented IPv6, he was at home one day and he suddenly realised that his boss's laptop, which was also at his boss's home, he could actually go through because they were both VPN'd into the lab. He could actually get onto the laptop, which was kind of He then sort of went, "Ooh, I wonder what he's got." Anyway, so yeah, we have to be very careful when we're doing the transition. So the topology of the network as it stands, we're talking about isolating various racks within the lab, so that they can't interfere with the rest of the lab. They can only break themselves. It may not even just be rack based, it may be even sub rack based. So we're calling them micro instances of dispatchers, and they may only have 2 or 3 devices attached to them, and so you want them so that they can update their dispatcher, they can do what they like, they can break it, they can start a DHCP server, a rogue DHCP server, and it doesn't kill the rest of the lab. In the IPv4 world, we will do that by basically subnetting and not allowing a bridge across. In the IPv6 world,
It is slightly more difficult, because I know a friend of mine who does goes into hospitals and stuff like that and sets up, and one of the guys said, I can see someone so's upstairs iTunes,
yeah,
and iTunes use IP version 6, and basically it was going through all their security because it was using IP version 6 and it was on the same network, so it could then get on there.
so the possible solution to that is to actually isolate them by IP address, by external IP address, by the top
You know,
3.
Isn't you really need a VLAN? Like, I mean,
Sorry?
you need the switch to be able to isolate it. You don't, because I mean, internally.
You mean do the isolation via the switches?
Right, because I mean, even if it's by external, they might be able to see other internal addresses, right?
Right, yeah. Yeah. No, I got you. No, I'm actually just thinking you have one of these micro instances has its own external, like that top 3 quads there. And so you can come in, will there be a physical separation? Probably not, because we want to be able to hop across from one to the other from within the lab, don't we?
Well, if they're on the same network, then they would be able to use the local link address anyway.
But does that mean that all those devices will be, even if I come in on this IP address, I've got this IP address, these devices here will be still visible from this one? Because it's a different...
Only if they were on, well, depending on how we
Physically
set
on
the access control lists on
right,
the...
okay, so it's just, that's a config
yeah,
issue.
yeah.
Okay,
That'll be the VLANs, and if we're using the sub-interfaces, with the access controllers there.
okay. Yeah, so I think what we're gonna have to do ahead of doing the IPv6 is, for every device that we can, we're going to give it a fixed address. And I wanted Bernie here because he says he has a use case. I don't know what the use case is. So, I mean, the only time we need that is when we need to do something like Pixie boot and things like that.
Or anything that's able to do a fixed IP address,
Oh,
it should be fairly straightforward.
well, it's just a DHCP serve, but you're going to get the MAC address. But when you have some devices, there are going to be a pool of devices this cannot apply to.
Yeah.
The ones who they come up into their bootloader with one MAC address, and then when you boot the image, they have another MAC address. Things like that.
Yeah.
So those are just always going to be edge cases that we just can't deal with, and we'll put them in this. We'll leave them in the 254 pool. We go, oh, it's one of those devices, and just run away. So, in terms of, I really wanted this as an IPv6 sort of like. Who's using IPv6 for testing? Is anybody actually using it in terms of testing their devices, or just using it as the addressing in their environment?
I use it at home.
Yeah.
I use it with my hosted machines, random places,
Yeah, okay.
part of daily life.
But I mean, people are going to want to test networking with IPv6 on devices in Lava, right?
One might hope that someone in the enterprise group would at some point
For
test that
example.
IPv6 works.
Yeah, yeah. Yeah, so, but we've had no requests, nothing.
Yeah, but you see, this is the curse of the leg group, right? It's not like we have actual requirements up front.
Yeah.
The requirement up front is work.
And IPv4 version 4 still does.
Yes.
So they're not moving on until they need to.
Until someone tries to deploy a 100,000 node installation in IPv6 and
Sorry.
holy crap.
So, with a lot of the, I mean, you know, the big thing going from 4 to 6 is that you can't remember the names. And so, is there any plan to having a DNS for all of the machines so that we can easily name them from
would need to do
external?
that. You'd need to have DHCP and DNS working in
So,
syncing.
but it would be
Because
DNSing the.
Right now, I don't think we use, do we use specific names for each
No.
specific device? Okay, so it's just one of those things where I think starting with that would probably be a
Yeah,
good step,
no.
next step, because we're not,
So-
like, here's your string and it's a little. like,
So IPv6 DHCP is surely redundant. It knows its own MAC
It
address.
doesn't. You can actually
I mean-
set up IP version 6 DHCP, so it will give out, but that's if you don't want to use this UIE 64 address method,
Right. Yeah. Yeah. Yeah.
which for some of the MAC address, the ones with the constant MAC address, we may be able to work some way of
Yeah.
using a DHCP to give them
So
fixed.
okay.
just if there's a subnet of names that
Yeah, yeah,
are
yeah.
more reasonable.
Oh,
so,
yeah.
Yeah. So we
That would be
at the
preferred.
moment the devices, because we don't even DHCP serve them, they don't have a DNS entry. But if we would have to do a proper DNS trawl of every device so that it's addressable by name. That would be a very nice thing to do, and the name should match the Lava device.
Even if you wanted to do something simple and still enumerate via numbers that map to things,
Yeah.
just breaking it down so that we just say, you know,
Oh, it's
whatever device in test 04,
Yeah.
you know, like dot lava
Yeah.
dot whatever, and you know that would be helpful.
Yeah, no, I agree. So actually, we should make that part of the configuration.
Well, we were on about doing diagrams and stuff as well, which
Yeah, but that's a special use case. But in this case, it's just I want to know the name of the device when I get into the lab.
yeah.
Although that may be going away. But
I don't know if there are any methods that. This is for IPv6 only or for IPv4?
No, I
and
think
IPv6?
we need it.
we need
now,
it for
don't
both.
we?
Okay, well, I think there might be some method that just that the DHCP once it assigns an IP address also updates the DNS,
DNS, yeah.
dynamically.
Yes,
So
well,
that
that's what I was saying the other day. I think there must be a way to make
I've seen it already working somewhere. In this
It
moment,
works
I have
in-
no idea
It
how
works
to
in
how to
Active
make it work
Directory.
right out of the box, but I know that
They must have got it from
You can
local
also
source
set just
somewhere.
static tables with the
Yeah.
classes that you care about.
Yeah.
That way it's-
I mean, that's basically the way
you don't
that
have
the
to really-
DHCP configuration is done. Is a series of include files, and they're all structured that way. And
but still, if we have to go for having such a mechanism anyway, just to go for the full one rather than
Well, the only thing
for a
with the
piece and then realize that you need also the other piece and then you have to
Yeah.
go over it again.
The trouble with the updating is that you're updating it based on what, and you might as well just do. I mean, if you're gonna have that division, you might as well just have an enumeration of numbers that then maps to an IP
Yeah.
inside of that subnet that just makes it easier to get to. than
Yeah,
during
do it all
the
in
six-
one.
you know,
Yeah,
120
absolutely.
bit string.
Yeah, okay.
Like,
yeah, okay.
because you can get nice things where people have vanity names and things like that for their systems, but
Yeah, yeah.
like
In this case, probably we just need a way to distinguish one device from the other rather than doing anything fancy.
right.
So it's just more being practical and having a way to
But-
get the
So in the DHCP config file, you actually put you put a name, but that never gets resolved as a DNS.
and that's a problem. If you put it in that's the point. If there is no DNS or DNS is not working, the device do not get
Right.
an address. So that is something that shouldn't happen, in my opinion, because in that case, you have basically multiple point of failures.
Yeah, yeah.
And it's easier that if something goes wrong or someone just updates the DNS configuration and makes a typo and it just restart the service or reload the configuration, the DNS says, oh sorry, I don't understand, I won't restart. Then you don't realize until you see that no device is getting any IP address because they cannot resolve the name and say, okay, there is no resolution, there is no IP address. You get stuck with nothing working.
Well, yeah, you should always do a DHCP D-T before you do a restart, because that actually
but
validates.
In the perfect world, yes, I agree with
Yeah, yeah.
Sometimes even the most careful person might, overlook or just miss something, and it's better have a good design up front, I think,
Yeah, yeah.
and figure out all the possible problems and minimize them rather than relying on the fact that one should
So
always use some best practices.
One of the actions we should take back from this is to actually look at how we can get the DHCP ISC to serve the name as well as the so that it acts as a DNS. Yeah. So, yeah.
I mean, it's just a matter of...
Because at the moment we're running DHCP and DNS mask. DNS mask is capable of doing DHCP as well. So.
Yes, but can it, for example, update dynamically itself?
No.
That's
So,
the problem.
yeah.
Which is something that requires probably something that has a little bit more capabilities, and being separated from being two separate processes, it's also probably a little bit maybe better. You can manage them separately on the same machine, on different machines, depending on which is the best approach. That is remain to be seen which way we want to.
Yeah,
exactly.
yeah,
I mean,
absolutely.
we are still figuring out most of this. It's nothing written on stone yet, so we have evaluated IPv6 because it can solve some of the problems without actually having to put into play some complex configurations. But also we need to have probably both the addressing on at the same time, because for tests people might want to test IPv4, IPv6, both of them.
Oh yeah,
and every possible configuration. We don't know. So
we have to maintain IPv4.
That's what's going to be with us.
The other part you might run into on the test side is when people may want explicitly, cases where DHCP doesn't provide an IPv6 to their machine. So it's one of those, if they want to make sure that their machine comes up and you're testing a distribution in an environment that is IPv4 only, that may come up, and then you may have a situation where they want to have both running, or where only one gets assigned.
Yeah,
so,
no,
those are more complicated, servery.
Yeah, in terms of test
district
environments,
testing.
yes, you want to check. That
And so, but that would greatly complicate your guys' setup. So
Oh, it
maybe
certainly
something
would.
that's something that partition would, say like that happens in another network or something. It's,
No,
I don't know if anyone's really brought that up. So that's just like
I'm not sure. So, so that would be one of these isolated multi-node tests that we. So the idea is that you can bring everything up on a master switch, sorry, on the main LAN VLAN, and then once they're all up, they can all switch themselves over to an isolated VLAN, which you could say, well, that's all IPv4, and so you could do that, yeah. But I wouldn't like to write a test, but you could do it.
As far as doing the initial rollout, is there any aspect of just kind of casually turning IPv6 on? I mean, the naming and all that stuff is nice when you don't have any other way of accessing something, but as long as you still have IPv4 numbers and people know what those are for their tests, they can still get to the machines. It's just having IPv6 numbers as well is useful.
Yeah, this is adding as opposed to taking the other one away.
Right, and so
they'll run in parallel and be brought up slowly.
So the idea is that we'll have an isolated network on which we will run all the tests and configurations and figure out all the problems before we actually just open up IPv6 in the lab.
Yeah. But it's one of those things I could also see, you know, the getting the DNS names and all that is useful, but at the same time, if all the machines still have IPv4 names, that's probably what people are still going to be using, because they, oh
Yeah,
I know.
yeah, no, it's
So
the sort of
one
thing we
those-
can, what we don't want is to just switch it on and go, oh, suddenly every device is
Yeah.
visible to the outside world. And
Well, and that's no problem for the we can.
As
Yeah.
far as I know, it's possible. It depends on the routers, but it's sometimes possible to mark all IPv6 package with a specific VLAN, and then all traffic will be in a specific VLAN.
Ah,
Only
right.
this VLAN will have, and if it's not routed outside, it will not go outside of the lab of this VLAN, and then you can connect one device. You can connect your laptop on it and test if it's working. At least on the routers that I was using when I went back school, this is what we did,
Oh,
and it was
okay.
working.
Fine.
Only IPv6 traffic was in a specific VLAN
Okay,
that was available on all routers.
right. That sounds interesting. Yeah, that sounds like a.
But it depends on your routers.
Yeah.
With Cisco's, I think you can do that.
We've got, yeah, it's all Cisco. Yeah.
So it should be possible.
Like the way my home router is configured, it's IPv6 is all denied. There's no, like, I can't even go in and configure a way to get IPv6 going. But everybody gets an IPv6 address internally.
Yeah.
And they can talk to each other, and they can go out and get, you know, normal, like, NAT-like behavior, but no incoming stuff. And that seems pretty sane as far as basic safety, that you don't have to worry about too much, but you still enable the functionality. And the only thing you don't get is being able to test public IPs at a v6 address. So, and I don't think anybody probably wants to do that, or I don't know, maybe. IPv6 testing from outside the lab internally, I don't know if that's a real use case. I mean,
If we permit IPv4 testing from outside the lab, then we should permit IPv6 testing out
but
from
you
outside the
don't,
lab.
because they're all 10 dot whatever
Yeah.
names, so.
But it's not an issue. I mean, the policy should be the same.
Yeah, so,
Yeah, exactly.
so
Yeah.
seems like that might be a simpler policy to go with, at least, just.
Just so the IP version 6 would allow us to actually allow you in, rather than forwarding a port. We could actually say, right, this address goes to this port,
And
and then you just literally land on the device. That's
so
what we're hoping.
the hacking sessions where you inject your public key
Mhm.
means that we could just say,
Just get.
there you go, that's open, SSH, you're the only person who can get on there because it's your key.
Yeah, and I see value in that. It's just that as in the steps to getting there, you may want to go with the simpler, just turn
Yeah,
it
yeah,
on, but
no,
nothing
no.
gets in and everybody can do their testing, and then sort of. You know.
It's just making sure that we
Yeah.
are firewalled properly before
Yes.
we switch it all on. Okay. Any more for any more? Right, thanks a lot. Early lunch.